Hey, what's up? It's Triggy. Today we're going to evolve an AI to play TRON, which is this sort of racing puzzle game where you compete to try to not hit the edges of the playing field or the walls that, I guess, sprout up behind you as you race. The controls are up, down, left, and right. And what we're going to do is create our own TRON environment with just a single player at first. So we'll start with this little fella in the middle of the board so that he's equidistant from the walls and let him at it. The game is being controlled by a neural network. We feed it some input about its environment, and then it performs some operation on these values, and spits out some output, in this case either up, down, left, or right. For a more in-depth explanation of neural networks, check out my last video. We will make 50 neural networks which perform totally random operations on these values, meaning that the movement is also going to be pretty random, and we're going to have them all play the game. They will mostly all suck, but a few will be slightly less sucky just by accident. The one that gets the highest score will be selected to repopulate, meaning a new generation of 50 players will be created. Each one of those will be a copy of the winning player from the previous generation, but with some slight modifications. This process continues, and eventually we get some neural networks that can actually play the game somewhat competently. The neural network will get to know the distance to the nearest wall in each direction, as well as the direction it's facing and its position on the board. You can see every once in a while it does okay, but he mostly just careens into the nearest wall. You'd think this behavior would eventually get bred out, but after 11 generations he's still as trash as he was in the first, so the inputs probably aren't sufficient. Before I actually put in the work to improve the code, let's see if adding some hidden layers will help. I mean, it won't, but let's try it. Yeah, they didn't. This worm thing is still remarkably garbage. And you know what? Just in case it works, it won't, but just in case, let's give the network all the information, so the position of every single wall on the entire playing field. Yep, that also didn't work. No problem. And real quick, it also won't help, but let's see if changing the field size makes any difference. Nope, and same thing with hidden layers. Nope, okay, back to the code. So it looks like the whole time the distance function was actually programmed wrong. I wanted to set it up so that if the wall was more than 3 blocks away, the network would get no signal. At 3 blocks, there'd be a signal of strength 1, 2 blocks away, a signal of strength 2, and if there was a wall right next to the player, there'd be a signal of strength 3. But I forgot to take the absolute value of the distances, so most of the time the input data was meaningless, so sorry little wormy guy. And yeah, I fixed that, and added wall distance in the diagonals. Oh, also, I broke up the position of the car into X and Y positions, which should help. I mean, if I put you in a dark room and told you were at the coordinates 7, 8, that would be way more helpful than saying you were in position 47. And right away, after just one generation, we get some very promising behavior. After a few more generations, he covers a good portion of the grid before hitting the wall, and if we start him in the corner instead of the center, he does a pretty decent job of covering the whole map. And in fact, he gets a perfect score on a smaller grid. If we take away all the information except for the position of the nearest wall in each cardinal direction, correctly this time, it actually does okay. Great, time to battle. So they'll each get to see the nearest wall in 4 directions, plus their XY coordinates, plus the XY coordinates of the opponent. After a few generations, they end up with some pretty high scores, but since they're both incentivized to get the highest score possible, they actually work together, since if either of them dies, the round ends. So it looks like they just occupy their own space and leave each other alone, which is actually pretty creepy. Yeah, it's really creepy. So let's modify the scoring function so that it incentivizes having the other player hit the walls that you produce. And look at that, this looks a lot more like a game of TRON. Ooh, check it out. Blue guy trapping red guy in a little pocket. Is he gonna spiral back out? No, okay. So there you go, thanks for watching, I hope you liked the video, and since you can't actually know how I live, I'm surrounded by a bunch of fish. After the last video, some people mentioned that maybe the neural network itself should be able to evolve, like the structure of it, the number of layers, the number of nodes in each layer, and I thought, that sounds really difficult, so I'm not actually going to do that, but then I ended up getting it, but only by the time this video was done. So anyway, next time I make a thing that learns with AI, the number of layers and nodes will evolve too, so that'll be fun.